All right, so in this video, I'll show you how to install this operator into Azure Kubernetes service. And we'll also deploy Azure Cache for Redis for a sample workload. To begin, you need to just clone down the repo into your local machine. So I'll do git clone. And then we'll drop into the repo. And then we can open it up with Visual Studio Code. All right, if you head over to the demo directory and the Azure Markdown file, this contains all the instructions that you're going to need to deploy this into your cluster. And so we took care of the first step here. And now we need to deploy the Azure infrastructure. Now there are two options that I've included in this repo. One option is to use the Azure CLI. So if you're comfortable with using Azure CLI, there's a few steps that you need to do here. So you'll need to create the resource group, create the Azure Redis resource, and then spin up a Azure AKS cluster. If you are familiar with Terraform and more comfortable with using Terraform, you can actually just run the Terraform script that I've also included in the repo. Let's go ahead and do that. So I'll drop into the hack Azure Terraform directory, and I'll be flipping back and forth between the instructions here and literally just copying and pasting. I'll initialize the directory to install the Terraform plugins. And then I will run the Terraform apply command. And so this will actually deploy. And if I just open this file up while it runs, so I can show you what's going on here. This actually deploys a resource group, log analytics workspace, an Azure Kubernetes cluster, and then also the Azure cache. So like I said, you're getting a little bit more bang for your buck here because it's deploying all this stuff all at one time, and it's doing it in parallel as well. So this will take a few minutes, and so we'll just have to just hang tight. It takes roughly around 15 minutes to complete. And what I'll do is do the magic of video editing. I'll go ahead and speed it up, and we'll be back in a few seconds. All right, looks like we're all deployed. Now we just need to grab a few variables from the Terraform output, because we do need to run some shell commands. So we'll pull out the resource group, the location, and the cluster name. And then also we'll pull out the Redis host and the Redis key. So let's go ahead and grab those. Okay, so we're all set, and we'll need to jump back over. Oops. We'll need to jump back up to the repo root. All right, from there, we'll grab the AKS credentials, and then we'll just make sure that we can connect to the cluster. That looks good. Okay. Now we can start installing components, and what we'll do is we'll install KEDA, and all the manifests are included in the hack directory. So we'll install KEDA version 2.10, and then we'll deploy a sample workload. And what this sample workload will simulate is it'll simulate a low priority job that will process items off of a Redis list. So let's deploy KEDA first, because that might take a few minutes. And often you'll want to wait for the external metrics to be available. So we'll just give that a minute or two. Okay, great. And like I said, the sample workload will pretty much be a batch or a long running process that just pulls items and processes them off of a Redis list. So let's actually populate that Redis list. And here I'm just going to run a pod and I'm going to call it add words. And it's going to run this simple Redis pusher that I wrote. It's available on my GitHub. And what it will do is it'll connect to the Redis host. It'll create a list called words. And it'll use our Redis password. And it'll push about 10,000 items into the Redis list. So let's just do that. And then you can see the job is running and we'll just wait for it to run to completion. Okay, good. So we'll bail out of that. Now we need to deploy the workload that'll actually process the items off of that Redis list. So let's clear this. And so what we're doing here is we're deploying a word processor. And what it'll do is it's just one long running job. Pull an item off the list, wait, I think 2 or 3 seconds, and then continue on. So we're pulling from this container here, and we're also passing in our Redis credentials. Okay, so we should see our workload is deployed, and right now we only have one replica running. The next thing that we'll do is we'll actually scale the job using KEDA, and we'll use a Redis trigger. And so the Redis trigger will basically say, hey, increase my maximum replica count based on the length of the list. So every time I see about 500 or so, deploy a new replica, right? Scale up based on the workload. And so I'm pointing at that word processor workload. Okay, and so that's deployed. And so now what's going to happen is you'll start to see that we have event-driven scaling in our cluster. Right now it's at 1 of 1 replica. And if you give it a minute or so, there we go. We start to see our workload is scaling out. So scaling out to 5 replicas currently. So that's good enough for now. What we want to do now is, remember, KEDA by default will scale up to a maximum of 100 replicas, unless you specify a different value, but the default is 100. So now what we want to do is we want to integrate, or we want to add the carbon awareness feature so that KEDA does not scale too high when it reaches a period of high carbon intensity, right? So that's what the operator is all about. And so to do that, we need carbon intensity data in our cluster to evaluate against, right? And so there is this open source repo that will use or take advantage of the Carbon Aware SDK, and it'll actually pull down carbon intensity ratings using watt time credentials. So it's pulling against the watt time data source, and it'll store the carbon intensity ratings into a config map in your cluster. And so the instructions are here. What you're going to need to do is you're going to need to have the watt time API credentials. You would export those into variables. And then from there, you can use the Helm chart that's included in this repo to install the operator there. So let's go install that operator. So I clone the repo down and I'm going to install using the Helm chart. Okay, great. So now let's head back over to my operator that we were working against. And let's just go check on the pods, make sure that they are running. And what we want to look for here is carbon intensity exporter, and you can see that it is running up for 25 seconds. Great. So let's check on some of the data here. So here I'm just doing a get on the config map that's in the kube system namespace. And the config map is named carbon-intensity, and that's what's populated by the operator. So you can see here that I have a little bit of data in the config map. It actually shows me the number of records that are in the config map, the minimum forecast, and the maximum. And these are going to be crucial as you start to plan out your thresholds for setting your minimum and maximum replicas. Excuse me, just your maximum replicas. If you're curious and you want to actually see the records, so it says here 288, you can actually run this command, which will query the config map for the binary data, and it'll pull out based on that key, and it'll decode it, and you'll be able to see all the data. All right, so we have our data, so our operator should be ready to start scaling based on the carbon intensity. What we want to do is download the installer for the carbon aware operator. So what you want to do is you want to head back over to the carbon aware KEDA operator repo, head over to releases, and you'll see the latest release is version 0.20, and there's a YAML file in here. Go ahead and click that, and that will download. And so what we can do is we can actually deploy that. So I'll do a kubectl apply, and I'll change this version number, and it'll deploy all the resources that's necessary for this particular operator. All right, so we are nearly there. The only thing that we need to do now is deploy our custom resource. And this custom resource will determine what we want to scale on. So in this case, we are scaling against the scaled objects KEDA target. And the scaler in particular is the word processor scaler that we just deployed a little while ago in the default namespace. And what we want to do is configure the carbon intensity forecast data source. The mock carbon forecast, if you don't have a watt time API credentials, no worries, you can actually set this to true, and the operator will just generate random carbon intensity values for you to demo and test with. But in this case, we have it deployed in our cluster, so we're okay with leaving this at false. And then for the config map information, you want to populate it with the name of the config map that you have in your cluster. In this case, it's carbon intensity in the kube system namespace, and the key here is on data. The important thing to note here is going to be around the configuration for max replicas by carbon intensity. The idea here is that they're going to be an array. They're going to be organized in an array of thresholds. And so this will give you a great deal of flexibility to determine what is high, what is medium, what is low for you. And if you want to have even more buckets of carbon intensity thresholds, you can do that. And so the idea is when the carbon intensity is lower, you want to do more. So you want more replicas. When the carbon intensity is high, you want us to do less, so have less replicas. And here you can define what's low or high. It's completely up to you. And I have 3 here just as an example, but you can literally add as many as you want. So what this is saying is 437 is a threshold. So anytime the carbon intensity is 437 or below, we'll consider that to be low, and we'll bump up the maximum replicas to 110. Remember, the default is 100, but we can actually go up further, so we'll do 110. When the threshold is 504, what this is saying is anytime the carbon intensity is greater than 437, but less than 504, so this is kind of like your ceiling limit, then we'll say, or we'll consider this to be medium, and we only want 60 replicas. And then finally, once the carbon intensity threshold is at 571 or even beyond, right, we consider this to be high, and we want to kind of drop it down to 10 replicas. We want to do less during the period of dirty energy. And if for any reason at all, you don't want the carbon awareness to be in effect because let's say you just need to get your job done, you have the option to turn off the carbon aware feature in your cluster. And we call that the eco mode off configuration. What this will allow you to do is set your max replicas. So this is effectively like your default. And what this will do is when carbon awareness is to be turned off, it'll just revert to this max replicas, which is 100. And then you have a couple different options in which to turn off the carbon awareness feature. The first option is carbon intensity duration. So this is saying if my carbon intensity is at or greater than 555 for 45 consecutive minutes, then we'll consider that to be a period of just high carbon intensity. We don't want to scale down our workload for that length of time. And so we'll just disable it based on this thresholds. And you can configure this to whatever you like. You can also use a custom schedule. So if you know of a particular date and time frame that you want this to be disabled, then you can set that here. And then lastly, you can set a recurring schedule. So here I'm basically saying every weekday from 11 p.m. to 12 a.m. UTC, disable the schedule. So we'll go ahead and deploy that. And then from there, we can actually check the status of the custom resource. And you can see that the operator is successfully reconciling and the eco mode is enabled and is using carbon forecast data from the config map. And it also scaled the word processor scaler down to 60. So we must be in a period of what I would call medium carbon intensity. Okay. You can also view logs from the operator. So if you run the kubectl logs command, you can view the logs, and this will help you troubleshoot the operator functionality. Okay, so everything is working. We're all deployed. We can view the status of our operator, see the logs, all that good stuff, right? The next thing that you would want to do here is you would want to probably visualize the carbon aware KEDA operator. And to do that, we can actually install Prometheus into our cluster. The operator is actually exporting custom metrics out, which Prometheus can scrape. And so we'll go ahead and deploy some of these manifests that are included with the repository. So we'll deploy, we'll actually install the Prometheus operator, and then we'll wait for that. And then we'll also deploy a service monitor. then from there, we will deploy the Prometheus and Grafana stack. And then it can take some time for the pods to get up and running. So we'll just watch the pods and we'll wait for the Prometheus pods to be online and up and running. All right. Looks like we are good to go. Now, let's also assign a cluster role binding to the Prometheus operator so that it can scrape metrics from the namespace in which the carbon aware operator is running out of. Okay. Now, finally, we want to browse to our Grafana website, but the service that has been configured for Grafana actually has a type of cluster IP. So that means it's only accessible from within the network or within the cluster. And so what we want to do is we can change the type to be load balancer. Remember, we're working in the cloud here. This is on Azure. Or we can port forward. It's just as easy to patch the Grafana service and set the type to load balancer. So let's go ahead and do that. And what's going to happen is the Azure Kubernetes service is actually deployed with a Azure load balancer, and it'll assign a public IP to the service. So we'll just give that a second or so, and then we'll run this command just to get the, it's a handy command just to get the URL out. And so I'll click on that and I'll open up Grafana in a browser window. All right, the default username and password for Grafana is admin admin. So you just want to push those credentials in, and then you'll have the option to change the password. But in this case, I'm not going to change it. I'm just going to skip through that. And what we can do here is now hop on over to the dashboards menu, expand that, and you'll see the import button. We'll click on that and you can see that it's looking for a JSON file. And for that, you can actually jump back over to the repo, scroll down to the hack directory. There's a Grafana subdirectory under there. And then there's a carbon aware KEDA dashboard JSON file. Click this button to download the file. I've already done that. So let's go ahead and just upload it. Select the data source, set it to Prometheus, and import. And what you'll see here is the data is starting to populate, and you can start to visualize what the operator is doing. So we can see here, the operator actually exports the carbon intensity. So each reconcile period, it'll write out the carbon intensity. It'll also write out what the default max replica was, so what that baseline was. So in this case, it was 100. And based on the carbon intensity, where it's set the max replicas to. So you can see here that with the carbon awareness in place, it actually lowered the ceiling, and the workload will never scale beyond 60 max replicas. Now, the data looks flat here, but over time, what you will see is something like this, where you start to see it really fluctuate. So this is installed in another cluster that I have, and I just let this run for a few days, and you can see that the carbon intensity starts to really ramp up. And so when it was down in the 400s over here, max replicas were actually, the ceiling was raised beyond the default, so we went above 110. You start to see a little spike here in the carbon intensity, and so it dropped down to 60. But you can see here that it started to rise in carbon intensity. But if you notice right here, it stayed relatively in line with what the default is. And the reason for that is because remember we had the eco mode offsetting that says anytime between 11 and 12 a.m. UTC, do not disable, or excuse me, do not enable the carbon awareness because we just want our job done at that hour. And so what happens here is high carbon intensity, but due to the eco mode off configuration, it actually left it at the default. And then here we start to see for the entire period, you're starting to see a really high carbon intensity. And so the max replicas was scaled all the way down to as low as it could go. And that's it. That's the carbon aware KEDA scaler. So your application is available is able to scale based on carbon awareness with no application changes at all.